one it says, find the weight X corresponding to the z-scores. Like it tells us the z-scores, so why would we find the z-scores? We can tell whether or not like we're using x minus mu over sigma or this one.
Yes, absolutely. But also, honestly, these questions, these would never happen to you in real life. Right now, what I'm trying to do is teach you how to use a tool. So on the back side is when we're actually going to be solving problems that would happen to you in real life. For example, no one will ever come up to you in your life and go, how do you use a ruler? No one. But people might say, how big is that? Or how long is that, right? And then you have to use a ruler to be able to use it. So it's my job to go, come here. Here's how you use this thing, okay? This is how this thing works. This side's centimeters, this side's inches. Here's how you do it so that when somebody asks you to use it that you can, which is what we're doing on the backside. So the backside is more like what you might actually get asked in a job or something like that and end up using this stuff. So let's look at the top one. It says, scores for the California Peace Officer Standards and Training Tests are normally distributed. I'm drawing a bell curve. With a mean of 50 and a standard deviation of 10, an agency will only hire applicants with scores in the top 10%. This 10% of people are going to be hired. What's the lowest score an applicant can still earn and still be hired by the agency? So this is an example of when, like if your boss came up to me, our boss came up to you and they said, hey, look, we only want to hire this top 10% of people on this test. We only want to hire the best of the best, the top 10%. Okay, but I want it to be out of their score and a bell curve, like really, aces up here. What's the lowest score they can get and still be in the top 10%? Do you see how this is a real life kind of question? Okay, so I'm going to use x equals z times sigma plus mu. X equals, looks like I'm going to need a z-score first. So what should I look up in the chart right now to find out that z-score? Should I look up 10% in the chart? I'm going to look up 0.9 because the chart always reads to the left. That's what we were doing earlier. Does that help? Yeah. So everybody's looking up 0.9 in the middle of the table. Even Gustavo's looking at it.
I already did it.
Okay. You were just staring into the distance, sadly. 1.28 I got. You guys get the same thing? Mm-hmm. So 1.28 times the standard deviation plus the mean. So this line here is a 62.8. Do you guys agree? Mm-hmm. So if 10% hits at 62.8, what's the minimum score they have to get? If their scores are only whole numbers.
63.
They have to get a 63 because a 62 would fall on this side. This isn't about rounding. When it gets to this, it's more about what side it falls on. So 63 is the minimum they have to score. Everybody okay with that?
Isn't it the minimum they would have had to score? Instead of being in the future, right?
Are we asking about like my English?
No, like
Past tense and present test, or are you asking about the math?
I like about the math. Because like if you couldn't use those numbers for like a different test, right? That has to be like for the past.
Right, so, but they're basically saying that in the past, people have had a mean of 50 and a standard deviation of 10. So now that we have some data from the past, now that we're giving this test in the future, we're only going to hire people who get a 63 or higher.
Oh,
Okay.
So would the like when you said with the rounding, it either falls on one side or the other. So even if it was like 62.2, it would
Right,
be
I'd still go to
63.
63 because a 62.2 would be too low. I mean, a 62.2 would be right on, but you can't get a 62.2, so a 62 would be too low. All right, your turn. Give it a shot.
This is, did we do something similar to this in intro to stats? Because it seems like oddly familiar.
We did, I think when I taught your class, we got through this section.
Yeah, because I remember.
We skipped all of chapter 4, of course, but like, all the binomial stuff, but we got through this section.
Because I remember somewhat like trying to find the number in between two.
Mm-hmm.
So what number did you get for that? 1%, so 0.01. That's our X value. No, we're trying to solve for X.
Yeah.
Doesn't matter, that's our Z.
Yeah. That's fine.
Oh,
Yeah.
You use a 16. I got 116.930.
Instead of giving them to you. Give them to you? Okay.
What did you?
1.6.
I got.
Make sure you're on the 16.
Pretty big change right there.
I think I, yeah.